All right, hello LinkedIn. I am here live again at the Strata Data Conference with Jed Doherty. He is a lead data scientist at Dataiku. Welcome to the show.
Oh, thank you very much. I'm happy to be here, Katie.
Thank you. All right, so why don't we start with talking about you. Who is Jed?
Who is Jed? Wow, so many things. I'm many within one. I'm the lead data scientist at Dataiku in the United States. Been with the company around 4 years. Love working at Dataiku. Love working in data science. It's been a wild ride.
All right, so you've been there for 4 years?
Yeah. So
Right.
since it was in the United States, at least, since it was me and my laptop, and now we're a few hundred people.
Okay, and so how big is Dataiku now? You said.
Around now, Dataiku is around 350 right now.
Okay, and how long has it been around?
We've been around officially since 2014. We really started growing in the United States at the end of 2015, 2016.
Okay, yep, I've heard of Dataiku before, so I've actually been to a conference, an egg conference, which is actually the same thing as Dataiku, for those who didn't know. So let's talk a little bit about what Dataiku does.
Sure, so Dataiku is an end-to-end data science platform. Works to help your data scientists, along with your data analysts and your data ops engineers, work together to ingest data, build out a data pipeline, construct machine learning models, and then deploy this whole process into production and monitor it once it's there.
Okay.
We really want to focus on giving multiple different groups, so multiple different types of folks like analysts, data scientists, ops engineers, all the ability to work together within the same pipeline, because we found that's really what people need.
Yep, I can see that. If people work in silos, that just doesn't work. So what type of clients do you serve? Are there specific industries or?
It's really all over. Since I'm based in New York, I work with a lot of financial services companies, a lot of banks, etc., hedge funds, etc. In addition, we work with big industry, so that's aviation, building any type of large machines. All of that requires lots of predictive maintenance work, stuff like that. Consumer public goods, marketing, it's really across the board. That's what really one of the most fun parts about working for this company is that I'm constantly presented with completely different challenges across different fields.
Yeah, that's great that you get your kind of hand in all the industries.
Yes.
That you'll never be bored, so that's good.
I hope not.
Yeah, so let's talk about some of the challenges that your clients are currently facing. What do you help people, what kind of problems do you solve?
So I think one of the biggest problems that I see in the industry right now is, you mentioned earlier, siloization, or people being siloed. Often it feels like the solutions for a small group of data scientists at large companies end up being untenable for a larger group of people. So you can imagine that a small group of data scientists doing the most cutting edge research at a large company end up using entirely command line based, fully code tools to build out some workflow. Then you realize you have 1,000 people also at this company who know a whole bunch about the business process and are utterly unable to, check something into Git, for example.
Yeah.
How do these data scientists and this much larger group that also should be able to contribute to problems like this end up working together? Hopefully Dataiku tries to help solve that problem, but it's definitely one we see all over the place right now.
Okay, great. So everyone who's tuning in, the topic that we're talking about today is you built a machine learning model, now what? So we're going to talk about that now. If you have questions for Jed on Dataiku or models or deployment or execution, please go ahead and put that in the comments and we're going to address them. And I see a couple people already joined. We have people from Mexico.
Hola.
Hi, Nicola. So why is it important to even talk about this? Tell us. I mean, people build machine learning models, data scientists, engineers, they build a model. Why do we have to care about what happens next?
Well, I think this industry, data science, has hyped itself quite a lot. I think everybody is aware of that. And a lot of that hype has been around, how amazingly predictive we can end up being with all of this great new data that people have been collecting over the last few years. It's super exciting. But then the actual successful deployments into production, especially at companies that aren't focused on internet or technology, are far, far fewer. So huge investment, huge promise, and then at the end, right now, not so much actual production. So figuring out how to deal with the part after you've done the initial pipeline, after you've created that initial model, I think is the question of the next few years for data science.
So who should care? Like, who's responsible for making sure something happens after a model is built?
It's a great question. It kind of the model that we've been working with that keeps not doing so great is one in which you have a set of data scientists, again, working alone, in isolation, building out...
In a dark room, in a closet somewhere?
Hopefully not a closet. Hopefully like, a cool room with a bunch of computers and, you know, like laser guns, Nerf guns at least.
That's a data scientist too.
Yeah,
Yes.
a lot of that. Little drones, good stuff like that. These guys build out their genius models.
Yep.
And then what they do is they take the probably Python Jupyter Notebook code that they've written up, and they take that Jupyter Notebook code and then they give them off to data engineers who are often in a different country. It's often offshored work in many cases, who are often very good, say, Java programmers or folks who are used to building engineering pipelines, and then ask these folks to replicate the work that they've done one time on one data set such that it works all the time on a constantly evolving and changing data set. And then these guys build something, takes 6 months, and then they put it into production, and the data scientists are over here going, oh, you built something, but it's not exactly what we built, it's not even close to what we built. So then it goes back, they fix it, and back, they fix it, and then it's 4 years later and nobody's put anything anywhere that actually works. So there's a requirement here that data scientists, data engineers, and even the analysts who understand what the end business cases need to be are all able to talk to each other. Otherwise, I don't know, it's very, very hard to actually make stuff work.
Right, so let's say the engineers are building the model. How can they ensure that when there's new data available or data that's constantly changing, is like you're able to feed that into the model? What can people do to address that problem?
So one thing, there's actually a couple great Google papers out on this. If you just look up Google MLOps, so they've released a few in the last year and a half. There's been a trend as people have more and more data to include more and more features in their models. It's like, why not? My model can deal with 500,000 features. Why shouldn't I throw 500,000 features into it? The downside of that is that the brittleness of your model is multiplied each time you add another feature. If this one feature ever goes away and your model requires it, so let's say, well, I'll give you an example in a minute. If your model requires a feature that disappears, then that model no longer works. You need to rebuild that model. So fewer features in a model aren't just good because it makes that model more generalizable and there's lower dimensionality, all the statistical reasons, but also because if you have something in production and over time you need to maintain it, the fewer pieces of data it needs to rely on, the better it's going to be.
But the clients want more. They want more features. They want everything.
Yeah, there's definitely a, maybe, and I wouldn't call it unfortunate, but a potentially unfortunate focus among machine learning researchers around chasing that AUC, chasing that highest possible number. Like, what makes a good model? Well, obviously the best AUC makes the best model. Who cares if I have to
Can
put
you
it...
define AUC for the audience?
Area.
I didn't know what that was, so please.
AUC is area under the curve. It's the receiver operated characteristic curve. It tracks true positives and false positive rate. Big curve. Anyways, you can look it up. It's very exciting.
So how many features should a model have? Is there like a... Is it 8? Is 8 the right number?
8 is it. 42, right?
42 is the meaning of life. Hold
there
on,
we
this
go.
can't be the same answer.
Why not make it the same? I think a model should have the minimum possible number of features that, let's say well, it's very hard to say, but basically you should take the minimum number of features that don't drastically decrease the quality of your model.
Okay.
Right? So if
That's
it lowers my AUC from 0.89 to 0.885, maybe that's not such a big deal if I lower my number of features from 2,000 to 40.
Right. Okay. So we have a question from the audience, from Bhushan Ramesh.
Cool.
He asks, what is the best way to productionize an ML model after it's built?
Cool. Great question. I'm not just going to plug Dataiku here because I can just be like, yeah, Dataiku, obviously.
Just use Dataiku, guys.
But there's two different ways that most people are productionalizing ML models. Maybe three if you count. Well, no, we'll go with two. So one is, do I need to, and the question that you need to figure out in order to figure out which kind of way you're going to be productionalizing is, do I want to batch score, or do I need to score models in real time?
Mm-hmm.
Or do I need to score records in real time? A lot of people think, oh yeah, I need to be real time, always. Like a lot of people
Real time
think
is best.
right. If it's not real time, what is it? But if your input features aren't also changing in real time, then it's much, much more efficient and faster to actually just batch score on a relatively regular basis and then do a lookup. No matter how great your model is, scoring a new record in real time is always going to be slower than a SQL lookup to something that got batch scored once a day.
Right.
So understanding when real time is necessary, I think, is a real key component of answering that question. Always worth asking yourself, when's the last time the data that this model is being constructed with get updated? Mm-hmm. And if it's not like 5 seconds ago, you probably don't need real time.
Right, yeah, that makes sense. All right, another question from Roger Mario Lopez Justinia. Wow, that's a long name, sorry. A question here, how would you design a new data science department inside a bank? Should it be inside the risk department or maybe something across the entire organization? Any thoughts?
Whew, wow. That's a really interesting question. So I work with one large New York City bank, and the first place that we actually built the data science organization out was inside the wealth management division as opposed to inside the risk department.
Wait, where did you build it? Sorry, I'm just multitasking. Say that again, I missed
inside
it.
the wealth management
Oh, wealth
division.
management, okay,
Yeah.
got it. Yep.
However, those were just the folks who were first on the curve, or along the curve. I think it's often going to be the case that different divisions within any large organization are going to be at different places within their technological journey, and maybe whoever has access to Hadoop first or a whole bunch of data first is the appropriate place to do it, as opposed to maybe a specific department.
Okay.
Risk is obviously a lot of really, really interesting questions. It's also a place that's very rooted in an actuarial past, I suppose, that maybe is going to be less willing to adapt to change than other parts of a major bank, in my experience.
Mm-hmm. Okay. So when you're building a model, how much should you think about or incorporate factors where you might need to make fixes or changes to the model? Is that important?
Yeah.
How?
Super important. Excuse me. So I alluded earlier to like feature count as something that's completely out of your control that can break. So I'll tell a funny story now. I used to work for this company that was doing a really cool thing. I thought it was cool. It was fun to work on. I was the only data scientist. We were a small company, seat of our pants kind of stuff. Basically, we were ingesting huge amounts of social media data. So we were sitting on top of the GNIB fire hose for Twitter, as well as Instagram data. And basically, every time people posted anything on Twitter or Instagram, we would look and see what the average rate of people posting in that exact location was, and if this was a huge spike, we'd identify it as a potential news event happening at that location. Mm-hmm. In this way, we were able to like super rapidly target, like say, an earthquake happening in a small Alaskan town, or a mass shooting happening in Nevada or something like that, because suddenly people are all tweeting about this. We beat the AP by like 5 minutes. All of a sudden, since we're all based on the public APIs of these companies changed their APIs to be more generalizable, or more generalized. So by default, Twitter used to give you exact latitude and longitude anytime you send a tweet. Thanks, Twitter. All of a sudden, they realized that was maybe a dangerous thing. Yeah. Turned that off, and it immediately destroyed my model overnight. So this was something that we were making money, and like things were going great. All of a sudden, one thing got changed, and nothing works. So like that's one thing where if your whole model is based on some type of data ingestion that you don't have control over, this is a very dangerous thing to base a business or even a model within a larger business upon. Kind of going to the other side of model problems, if your model is 10,000 lines of Python and you're the only person who knows how it works, that's a huge liability in and of itself. in and of itself. You might leave next week. You might go to Google. If you build a 10,000 line Python model and it works really well, you're probably going to go to Google. Which means your company right now is going to be set with a model that they can never change. So if you start seeing model drift, or you start seeing feature change, like I just said, they have nothing they can do about it. Heck, they may not even know how to redeploy it.
So how do you mitigate these types of risks? Meaning like dependence on outside data or dependence on people? Because we always are going to depend on external sources, right? For the most part, we can't collect all the data ourselves.
Right.
And we have to hire people.
Yeah.
We can't write all the code ourselves either. So how do you mitigate this risk?
I think one thing is either choosing tools or a platform that encourage transparency, encourage documentation, and encourage de-siloization. So really keeping, allowing analysts to understand as much of a data science workflow as possible.
Yeah.
It's incredible, right? Because then instead of having 10 data scientists who might really know how something works, you have 500 analysts who pretty much know.
Right. So pretty much know is better than one person.
Then nobody,
really
one guy knowing everything. Maybe only one guy really does know everything. That might still be the case.
Yeah.
But if 500 people each know 30% of something,
they can work together.
They can work together, and it's a lot faster to update people.
Yep, makes sense. All right, another question. How would you tackle when you have noisy data and you don't have a golden data to start with? So creating a training data only option is to use manual annotation.
So this is a cool question. So you have no input, basically you have no input labels. So you have a whole bunch of messy information, and you know that this information pushes something out, but you're not even sure what you're supposed to be looking at here. So there's two different, there's kind of the mechanical option, and then there's the human option. Probably lots of people have heard of Mechanical Turk. So for those of you who, so if you haven't heard of Mechanical Turk, the original Mechanical Turk was this dude who hid inside of a fake robot back in the 1800s, and he tricked people into thinking they built a robot that was really good at chess. But he was actually just a midget who was really good at chess.
Seriously?
Yes.
Okay.
The underlying concept of this is that de-annotated data, or any kind of data that you're trying to label, it's often best to just have humans label it first, and then you can pass it into a supervised machine learning algorithm and figure out how a machine could label it later.
Okay, so don't let the machine
In
go
fact,
wild at first.
Right.
Give it some help.
Yeah, so in fact, Amazon does have a service called Mechanical Turk. Alibaba has a similar service that is basically just you give a whole bunch of data to people, and then they go ahead and label it. And
interesting.
They get paid like 1 cent per labeling or something like that. The other side of that is to use an unsupervised model as opposed to a supervised model. So if you have a strong idea that, I have all these records, I know they should cluster up in some way, but I'm not really sure what the exact parameters of what clusters them is, or what would cluster them, then I can throw it into a unsupervised model, so like a k-means model. And that will isolate them into clusters as best it can. Ideally, then you should be able to look at the results of that and see whether these clusters intuitively make sense.
Right.
So with unsupervised models, there's always a lot more kind of human decision making that needs to happen before you decide it's worthwhile or not.
Right.
There's really no good single metric that says, there's no good single metric that says, all right, this unsupervised model is working well versus poorly.
Okay, so you'll still need human involvement at some point.
Definitely, you need to say, oh wow, these clusters make sense versus, wait, I have no idea why this would happen. This seems like maybe a random effect of the data.
Yeah, okay. All right, next question, Nazilla. Do we need to revisit a productionized trained model to ensure it's working well as we had planned and started off, and how often? Cool,
so this is, this question literally everyone is asking about right now. Part of the issue with revisiting a productionized trained model, and we were just talking about this, is that to know whether a model is doing well or not, you need to eventually pipe the ground truth back into it. So if my model makes a guess on whether someone will click on an ad or not, then eventually we need to find out if they actually clicked on that ad, and that's how we're going to find out if that model's good or not, right?
Yeah.
So we can pipe that information back in every so often, understand if my model is drifting. Normally, I wouldn't have it arbitrarily automatically retrain every month. I would have it retrain if the drift has changed a certain amount. And I probably wouldn't even have it automatically retrain. I would have it first warn my data science team that, okay, my model is drifting, allow them to investigate why before auto retraining, just in case your model is completely collapsing and then it's just wastefully redeploying itself.
Yeah.
The downside of this whole thing, and something that people don't talk about enough, I think, is that in marketing, yeah, it's pretty easy to find out if somebody clicked on the ad on your website. But let's say I'm doing a model that tries to predict, I don't know, whether somebody will default on a loan.
More risk.
Not just more risk, but more time. I might not know if they default on the loan for 10 years.
Yeah.
So how do I know if my model was good or not? I don't have any feedback loop here.
Mm-hmm.
So the longer lifespan decision the decision your model is making, and the higher risk lifespan a decision your model is making, as in, let's say we're instead training a model that decides whether a car stops or goes at a stop sign. Car only needs to run a couple of red lights before you got a real problem, right?
Yeah.
So higher risk decisions, or basically decisions where the model being wrong results in a catastrophic failure very rapidly, or where the model being wrong you don't know for a long time, understanding when you should retrain or how well your model is working is a much more challenging conversation.
And how do you address that? So for a longer lifespan, for example, defaults, is there a solution for that?
I mean, there's not a pretty solution, honestly.
Can you solve all the problems right now?
Yeah, I got 4 more minutes here. No, there's not a pretty solution. Being smarter about your holdout data.
Be smarter.
If
That's a solution. Be smarter.
Be smarter about your holdout data.
Just do better, guys. That's it.
So essentially, if you have a large data set, a large static data set with which data scientists often start with, you're going to need to, you're building your initial model on that static data set. You'll probably need to be a lot more careful about what you hold out and how fast you decide that, all right, I have used too much of my data. I have repeatedly iterated over trying to optimize for the same existing data. I really should no longer believe that any model I build is going to be able to externalize or continue to work on new data. It's a whole long topic, but yeah, it's quite hard.
Yeah, I can see that being a huge challenge.
Yeah. Again, a good solution there is assume that an extremely complex model working on extremely long time spans or extremely challenging problems in which being wrong is very, very bad.
High risk, yeah.
Yeah, is probably not what you want. You want clear indicators from a simple model before you put something like that in production. And in fact, federal regulators in most of these industries require that. They don't want a 500 input feature model. They want a 4 input feature model before they'd approve it to say approve or deny loans.
Yeah. So Sagar is asking, does feature engineering require an ample amount of experience?
Depends on what kind of feature engineering. I think that useful feature engineering is greatly, greatly helped by industry knowledge.
So domain expertise.
Yeah, domain expertise is extremely useful for useful feature engineering. Analysts were going to have the potential to be able to be useful for a long time still. I don't see that going away. You can do a lot of simple feature engineering with the click of a button, which I see a lot right now. A lot of folks are saying, well, why not I just take all my features and multiply them together, and some of those are going to be useful, and then we'll figure out why later. That's not necessarily a bad thing, but you definitely want to figure out why before you decide to bank your company on them.
Right. All right, you ready for the next one? All right, for normal ML models, it's known to see which features are causing predictions result, but for what's causing the prediction result. But for deep learning models, what are the best ways, according to you, to troubleshoot what's causing the model to predict? So basically, ML is easy to see what's causing predictions. Deep learning is not as easy.
Yeah, deep learning is much harder. So if we're speaking specifically about the easiest one with deep learning that to figure this stuff out with is images. So with images, there's a lot of open source tools and closed source tools, but really open source tools that allow you to see which layer of an image or which cells of an image each layer of your model is focusing the most on. And it's still a very human process, once again, of like, oh look, it said it was a cat, and look, the layer, highlighted that cat's face.
Right?
Yeah, or an avocado.
There's like a thing, yeah, or like a puppy, and there's like a little puppy face and a blueberry muffin, and they look almost exactly the same. Yes.
But it knows it's a puppy.
No, it doesn't.
It doesn't know.
Yeah, it confuses them.
So
we're not there yet.
Yeah, I think that's still a pretty challenging question. And one of the downsides of, again, putting deep learning into place in a situation where either you have a very long time frame on being right or not, or you have a very high risk when you're wrong.
Right.
So I think that's why we see deep learning mostly for like things like hot dog, not hot dog. You're like, I already know it's a hot dog. Oh yeah, this thing's a grease.
Wow, it confirms. I can eat
Obviously, there's a lot of more interesting deep learning applications out there, and
right.
it's an incredible field. But I do think that most of the current applications there are in either not incredibly high risk or not incredibly long-term situations.
I'm sure there are things in the works that we might not hear
Yeah,
about
so
yet.
I actually, this is a funny side story. I have a friend who works, he builds object recognition software.
Okay.
And his object recognition software is all hard-coded with heuristics, no machine learning. And people in defense and people in surveillance are all really happy about that.
Why is that?
I think it's because, given a situation, they know exactly what his product is going to do and exactly why, and he can tell them. And with a comparable deep learning solution, they don't, and that really scares them because they don't have the ability to say, okay, this is why you actually accidentally blew up that wedding party instead of the car.
Yeah, I actually wanted to touch a little bit on like the black box concept of models and when they're built, and most of the people who ask for the model don't know how it works or don't know how it breaks or all the kind of assumptions that it made. Do you have any thoughts on how we can fix that problem, I guess, in the black box excuse?
I think black box is. I think the black box sometimes really doesn't matter. Sometimes it's fine.
Yeah.
I'm sorry to keep harping on this, but I think in some cases the black box will never be a good choice. If you can't say why you did something and it puts somebody in harm's way, then I think it's morally irresponsible to use a black box.
Mm-hmm. Yeah, especially with like the responsible AI and ethics and all that. I mean, I have a lot of thoughts on ethics, but I guess that would be for like a different session. There was one question from Nabil about what kind of industries are, I guess, applicable for data science. Do you have thoughts on that? Which industries are better for data scientists in terms of those who are looking for work?
Let's see. Obviously, there's huge interest from fintech right now.
Okay.
I think that's a huge and very popular industry to dive into. Any industry, so it's funny, across all industries, except fintech, so fintech is a different set of problems, but really most other industries, the problem that I keep hearing about across everything else is basically supply chain management. Knowing when a certain amount of product should be in a certain location is still an extremely, extremely challenging problem. And the misses on either side of either under providing a product or over providing a product are still places where lots and lots of companies can optimize big time. And predicting demand, which is a machine learning problem that machine learning is actually shown to do a great job at, as well as predicting weird oddities in, let's say, transportation time, things like that. These problems go across industry. So those problems are if you want to ship a T-shirt to, from India to San Diego, or if I need to ship a bolt from, for an oil pipeline from Houston to Russia. It's the same basic problem. Yeah. And I think knowing a lot about that, knowing about the best ways to optimize that are huge. Everybody wants that.
All right. Well, before we wrap up, I have a question about this movie, The Data Science Pioneers. Please
I'm not in it.
Tell us about this movie. Where can people find out more, and when can they see this?
So yeah, Dataiku has helped to put together a movie called Data Science Pioneers. It's premiering across the United States over the next few weeks. You can find out how to find showtimes. It actually talks a lot about what we've just been talking about here in this conversation, but you can find showtimes as well as how to find places to go watch it at datascience.movie.
All right. Well, if you guys have any more questions on anything related to machine learning, Dataiku, or models, please message Jed directly. He'll be happy to,
I'm around.
to address all questions. Thank you again for your time, and thanks for being on the show.
Thank you.
All right.
Bye.
Bye everyone.
Oh yeah.
Yeah. You're